Okay, this is a continued tutorial on 3.1.1 transformations. We were up to reflections with geometric figures. A quick review about reflections. That's when we flip a figure. All right, so we typically flip over lines, and that line that we flip over, in the past has been the y-axis or the x-axis, or even some line y equals 2, x equals 4. And we can even go crazy with the diagonal line, something like y equals x. We could flip over all those lines, but we flip over lines because our reflected shape or our image ends up being equidistant from that line that we end up flipping over. So we call that the line of reflection, and that's, again, the line that we flip over. What I've got here set up already is our pre-image triangle ABC. I've written out in words what we're going to do. We're going to reflect over the x-axis. Now keep in mind that the x-axis is a horizontal line, y equals 0. All right, so everything that's below it, when we flip, are going to be above it. So everything's going to be the same shape. It's going to be congruent. This is going to be an isometric transformation, but we're going to be mirror image above the x-axis. So here we go. So we're going to go ahead and do that right now. So one of the things that's really important to keep in mind when we do this is that you want to make sure you're the same distance on the other side. So for instance, if I go ahead and identify this x-axis here as my line that I'm going to line of reflection, I want to make sure that the units of my new A are going to be the same units away. So if I'm going above it, right now I'm currently 1, 2, 3, 4 units below. Now I'm going to be 4 units above. 1, 2, 3, 4. This is my new A. Notice my notation, it's been moved once. My B value, my B point rather, is below 1 unit, so now it's going to be above 1 unit. Again, notation showing that it's been moved. My C has been down 1, 2, 3, 4, 5, 6. So I'm going to go up 6 from the line I'm flipping over. 1, 2, 3, 4, 5, 6. And there you can see the triangle that is our image after we've reflected triangle ABC over the x-axis. We're going to go ahead and put the coordinates for the new points and write out this coordinate notation. So my new A value, that was right 8 and up 4. My new B value was right 5 and up 1. And my new C value is right 1 but up 6. Okay. So what we just did is we again reflected over the x-axis. So if you take a look at the original points or the pre-image points, 8, -4, 5, -1, 1, -6, and you compare those to our image points, 8, 4, 5, 1, 1, 6, you should notice that the only thing that has changed is the sign on the y values. Notice that the x values are the exact same. So all we did is change the y value. So we kept the x value, but did the opposite of the y value. Continuing with our theme, we're going to now reflect triangle ABC over the y-axis. Now our y-axis is a vertical line. X equals 0 is the equation for that vertical line. So this is going to be a horizontal flip, so I'm flipping from right to left. So everything that's to the right of the y-axis is now going to be to the left. Sticking with the same idea previously, we want to make sure that we are equidistant from the line of reflection. So at the moment, A is currently 1, 2, 3, 4, 5, 6, 7, 8 units to the right of the y-axis. Now we're going to be 8 units to the left. 1, 2, 3, 4, 5, 6, 7, 8. There's my new A value. I could go with my B value. It's currently 1, 2, 3, 4, 5 units right. So now I'm going to go 5 units left. 1, 2, 3, 4, 5. And our C value is 1 unit right, so it's going to be 1 unit left. Again, making sure that I note that it's been moved once with that notation there. If you take a look, you can see the two triangles are congruent. They've just been flipped horizontally, so they are mirror images of each other, left and right. And take a look at what the coordinates for my new image points are. A is -8, -4. B is -5, -1. And C is -1, -6. And if you take a look at that, all of the X values have been flipped, or we've done the opposite sign, but all the Y values have stayed the exact same. So what we've done here is we've done the opposite of the X, and we kept the Y value. So there's our coordinate notation there for what we've done, flipping horizontally over the Y axis. To example 4 and talk about what we've got here. Basically, we've got the pre-image and image graph for us. We're just going to explain what happened to it. Now, the notation really tells you which is the start and which is the finish, which is the pre-image and which is the image. And as you can see here, A, B, C, D, and then we've got A, B, C, D with those markings that they've been moved once. So that's an indication that this one is the image and this is the original or the pre-image. So it looks like I've been flipped over the y-axis. So that means all of my I'm sorry, let me start that again. I flip over the x-axis before I misspeak again. I'm flipping vertically over the x-axis, and that means all of my y values have been changed, but my x values stay the same. So we reflected over the x-axis, and we'll be even more specific and say A, B, C, D over the x-axis. The coordinate notation, when we reflected, we changed all the y values. So we kept the x's, but we did the opposite of the y's. Now to example 8, where we've got a new line that we're reflecting over. This time it's y equals -2. The y equals a number indicates that it's a horizontal line, but it's not one of the axes. It is a horizontal line going through -2. So in blue, I went ahead and drew that in just to remind you really quickly what y equals -2 would look like. Keep in mind that x equals -2 would be a vertical line going through -2 on the x-axis. So that would be a different type of flip. All right, so this time what we're going to do is if we're going to flip over this line, everything that's below it's going to go above it. Everything that's above it's going to go below it. We don't really have that, but we do have this interesting point I here, which is actually on the line. So when we flip it, just like if you were touching a mirror, your mirror image is touching the mirror as well. So that point's actually going to end up staying on the line. So Q, I think this is looking like an X here. E, Q, X, and E are all going to go above, but this I looks like it's going to stay in the same place. So here we go. Keep in mind that Q is 2 units below, so it's going to go 2 units above. There's the new Q value. X is 3 units below, so it's going to go 3 units above. New X. E is 1 unit below, so it's going to go 1 unit above. And again, notice that I, because it's on the line, it's going to stay the same. So now we connect our vertices of our quadrilateral, and you should be able to see that the pre-image and the image are congruent. So this is an isometric transformation, but it's a mirror image flipped vertically over y equals -2. Okay, now we're going to do example number 9, where we're going to have a reflection over a vertical line, x equals -1. I've already got that drawn in for us here in red. And so that means that we're going to flip horizontally over this line. So everything to the left is now going to go to the right, keeping everything equidistant from the line of reflection. W is 1 left, so it's going to be 1 right. There's my new W. S is 1 left, so the new S is going to be 1 right. There's my new S. Okay. I is currently 1, 2, 3, 4 units away, so we're going to go 1, 2, 3, 4 units right. New I value. And P is 1, 2, 3 units left. So now we're going to go 1, 2, 3 units right. And we can connect our vertices for our quadrilateral. And again, you could see they are congruent, pre-image and image, isometric, but we've reflected horizontally to have mirror images equidistant from the line of reflection, vertical line, x equals -1.